You might be thinking this right here is pretty easy because first we know 2 to the third power is equal to 8. So we can just say x is equal to 2 and y is equal to 3. And then just add 2 and 3 together. That's equal to 5. Is 5 the answer? No, because we could also do the following. What if I put x to be square root of 8, y to be 2? The square root and the square will cancel, so we'll still get 8. And in this situation, square root of 8 plus 2, work that out, you'll get approximately 4.828, which is smaller than 5. So does that mean this is the answer? No, because what if x is another irrational number? So in fact, in order to solve this question, we will have to use the Lambert W function. But before I go over that, let me just tell you guys why we are looking for the minimum. Because you can make this expression as big as you want. For example, since I have the condition x is greater than 1, I can say, let's say x is equal to 1.01. If x is this, then for y, I can just make that equal to log base 1.01. So they still cancel. But for the input, I will have to put on 8. So altogether, I will still end up with 8. And then if I add this and that together, 1.01 plus log base of 1.01 of 8. This right here, you get approximately 209.992. Yeah. So if you put x to be closer and closer to 1, the result will be bigger and bigger. And you can also try if x is in between of 0 and 1, not including 0, not including 1, then you can play around with that. But anyway, so let's take a look at how we can solve this question. Okay, so first we are going to start with this equation. X to the y's power is equal to 8. And then we would like to solve for y. So that way we can write this in terms of just x. And to do so, let's take the natural log to both sides. That way we can bring the y to the front. So we see this is just y times ln x is equal to ln 8. And then divide this to both sides. So we get y is equal to ln 8 over ln x. And now I'm going to put that right here. And I'm just going to call the result to be our function f of x. So we have x plus, and you know, we are going to take the derivative pretty soon, right? So I'm going to write this as ln 8 times ln x raised to the negative 1 power. Now, to find the critical numbers, we will have to find its first derivative and then set equal to 0. So the derivative is just going to be, first we have 1. Here we can just use the power rule because this is just a number. So we can just bring the power to the front. So we have minus ln 8 times ln x. And then of course subtract 1 here, so we have negative 2. And don't forget the chain rule, multiplied by the derivative of the inside, which is 1 over x. And I'm going to put them a little bit nicer. So this is 1 minus, this is on the top, over, let me write this down first, and then ln x raised to the positive second power on the bottom. That's the derivative, and let's go ahead and set this equal to 0. Now, we have 1 minus this thing is equal to 0. In order for this to be 0, this has to be equal to that. So we will have to focus on the equation x times ln x to the second power is equal to ln 8. Now, how do we solve for x here? Well, have a look. We have x multiplying with a log function. So this is a good chance to use the Lambert W function. And of course, I'm going to give you guys a quick review, and you know it's coming. Yes, it's the fish. Have a look here. In order for us to use the Lambert W function, first, you should have a fish. And then you should have the e, and then raised to the same fish power. If you have that, then congratulations, because you can then just take the Lambert W function, and you'll just get the fish back. How wonderful. Now, how can we put this into this form? Here's the strategy. First, we want to see the e. Okay, so how can we introduce the e? Check this out. right here we have an x. I'm going to purposely write that as e raised to the lnx power. This works perfectly. E and lnx cancel, and of course right here we said that x is greater than 1, so works wonders. Okay, so now we have the e, and of course we still have that in the front, so we have lnx squared, and that's equal to ln8. Now what though? Well, lnx, it's not a fish yet because this and that are not the same. Well, this is to the second power. Can I somehow make this to the second power? No, because if I square both sides, then I will just have to multiply this power by 2, right? I cannot square both sides. So it's actually easier to get rid of the square here because we could just have to take the square roots to both sides. And technically we should have the plus or minus. Okay, that way, square root of this, we will just get lnx. And then square root of this, square root is the 1/2 power, so we can just take 1/2 times this power, so we have e, and then here we have the 1/2, and then lnx. And on the right hand side, we have the plus or minus square root of ln8. Okay, so now this is kind of like our fish, yeah? But I need this to be the same as that, so how can we do it? Well, I need a 1/2. So why don't we just multiply this equation by 1/2? So multiply 1/2 here, and likewise multiply 1/2 here. Okay, this is exactly the same as that now, so congratulations, because we can then use the Lambert W function. So I'm going to put a big W here, and then likewise here. So on the left hand side, we will just get the fish back, and we can just write this down one time. That's 1/2 lnx. Now, on the right hand side, remember here we have the plus or minus. Do we take both, or do we just take one of them? Well, it's just one of them. Because if you want to stick with real numbers, especially I said that x is greater than 1, then we will have to worry about the domain of the Lambert W function. And let me remind you guys right here. If we have w of x to stick with the real numbers, we need x to be greater than or equal to -1 over e, which is about -0.3 something. If we have -1/2 square root of ln8, that's about -0.7 something, which is not in the domain of this. So I'm going to get rid of the negative. Okay, so we're just looking for this. It's equal to w of that. So w of 1/2 square root of ln8. Okay, multiply both sides by 2. So this and that cancel, and then do e to the power, so this and that cancel. Ladies and gentlemen, we can get x being equal to e raised to this 2 times the Lambert W function power of 1/2 square root of ln8. So this right here, it's the critical number in the exact form with the Lambert W function. And to get a decimal approximation for this, you can use Wolfram alpha, enter the w as product log, which is very similar to the regular natural log, and you will get approximately 2.49 something something. Okay, so now we have this. All we have to do is just put this into our function, and I'll tell you that will give us the minimum. So the minimum is just that f of e to the 2w of 1 over 2 square root of ln8, and then you can use Wolfram alpha or whichever software that you want. Compute it, you will get approximately 4.7694. And I will tell you, this right here is the answer.